All right, some e to the x integration. The rule. So the antiderivative of e to the x is e to the x plus c. Okay. E to the u would be, with respect to u, is e to the u plus c. All right, let's integrate. I need to take my exponent and set that equal to u because I know how to integrate e to the u du. So let's figure out what our du is going to be. So I have du, the derivative of u is du dx, and then I'm going to take the derivative of the right, which is 3, and then dx. So I'm going to move the dx over to the other side. Okay, so I get dx is equal to du over 3. Okay, so when I substitute my dx, I'm going to end up with du over 3. So that would be 1/3 times the integral of e to the u du. So 1/3, and the integral of e to the u is e to the u plus c. And then we just substitute back our u. So 1/3 e to the 3x plus 1 plus c, since this is an indefinite integral. All right, number 2. Here we go. This one looks a little grosser, but let's try. Well, I'm going to try that trick. Set the exponent to u since I know how to take the integral of e to the u. So u is equal to negative x squared, and then du is equal to negative 2x dx. And then I'm going to divide both sides by negative 2x. So dx is equal to du over negative 2x. All right, let's see what happens. I get 5x, the integral of 5x times e to the u times du over negative 2x. I see the x's cancel, and I'm going to pull out the negative 5 over 2 to the front, and then I'm taking the integral of e to the u du. So I get negative 5 over 2 e to the u plus c. I'm going to look back and remember that my u was negative x squared. So I get negative 5 over 2 e to the negative x squared plus c. Let's do another. Okay, okie dokie. Let us see. Same trick. We know how to take the derivative of e to the u. So let's make 1 over x equal to u, which I remember as x to the negative 1. So du is equal to negative x to the negative 2 dx. So rewrite this as negative, my paper's in the way, negative 1 over x squared dx. And then I'm going to multiply both sides by x squared. So I get, and a negative 1. So by negative x squared. So I get negative x squared du is equal to dx. All right. So I get e to the u over x squared times negative x squared du. How nice is this? Cancel, cancel. So I get negative e to the u plus c. And I take the integral. Actually, you know what? I'm going to write it nice. I get negative e to the u du, which integrates to negative e to the u plus c. So I get negative e, my u is 1 over x, plus c. Next, the integral of sine x, e to the cosine x. And again, I know how to take the antiderivative of e to the u. So let's try. We might as well just try and make the exponent the u value. So du is equal to negative sine x dx. So dx is equal to du over negative sine x. Let's see the magic. Sine x times e to the u du over negative sine x. The sine x's cancel, leaving me with negative times integral of e to the u du. So negative e to the u plus c. My u value is cosine x, so I get negative e to the cosine x plus c. Ooh, we're whipping right along here. Number 5. Okay, I got a definite integral. Ooh. All right. This one's a little trickier because I got this stupid denominator. It's not stupid. It's just tricky. So I'm going to try and make the denominator equal to u, because I know when I take the derivative of 1, I'm going to get 0. So I'm hoping that I end up with a monomial and in the denominator, and I can simplify a little bit more. Okay, let's see what happens. I get du is equal to the derivative of 1 is 0. The derivative of e to the x is e to the x dx. So dx is equal to du over e to the x. All right, so I'm going to take the integral. Let's change the balance in a second. Let's make sure this is going to work. So I have e to the x over u times dx turns into du over e to the x. Ta-da! And they cancel. All right, so next up, we need to change our bounds. So I have u of my lower bound is 0. So 1 plus e to the 0. Anything to the 0 is 1. So I get 2. And then u of 1 is 1 plus e to the 1, which is 1 plus e. Okay. So now let's go ahead and write this nice. I get 2, the integral from 2 to 1 plus e of 1 over u du. And I remember back 2 lessons ago that the antiderivative of 1 over u is ln of the absolute value of u. And since it's a definite integral, I do not need c. So I do from 2 to 1 plus e, and we're going to substitute in the difference here. So ln of 1 plus the absolute value of 1 plus e, which I already know is a positive number, so I can actually change that to parentheses, minus the ln of the absolute value of u, which is 2. Okay. So then I remember that when you subtract logarithms, you can apply the quotient property. So I have the ln of 1 plus e over 2 is my answer. It's not the nicest number, but it's a number. Okay. All right. So one more. This is a another kind of trickier one where we have an indefinite integral. So we're going to have a c value. Okay. I notice that I have a monomial in the denominator. So let's go ahead and divide it in. I get the integral of 2e to the negative 3x plus, let's say I have e to the 1x minus 3x, so e to the negative 2x dx, okay? And since I now have a polynomial, well, it's not a polynomial. Since I have terms, I can split my integral into 2 integrals. So I have 2e to the negative 3x dx plus the integral of e to the negative 2x dx. Cool? Cool. All right. Now we just need to integrate these. I'm going to make my u equal to negative 3x. So du is equal to negative 3 dx, and dx is equal to du over negative 3. All right, so I get 2 times the integral of e to the u. And then instead of dx, I'm going to replace that with du over negative 3. Plus, all right, so since I already used u, I'm going to use v for negative 2x. So dv is equal to negative 2 dx. So dx is equal to dv over negative 2. All right, integral of e to the u. Nope. E to the v. And instead of dx, we're replacing that with dv over negative 2. So the integral of e to the u, I might as well rewrite this. This is negative 2/3, since I have the 3 in the denominator, of the integral of e to the u du plus negative 1/2 times the integral of e to the v dv. All right, let's do our integration. All right, so I get negative 2/3 e to the u plus c1 plus negative 1/2 e to the v plus c2. Check it. I'm going to combine c1 and c2 into one solid c. It represents c1 plus c2, but it's just a third value that it's just a constant. Okay. And then at the same time, let's replace the u and the v. So I get negative 2 over 3 e to the negative 3x minus 1/2 e to the negative 2x plus my c1 and c2 make one solid c. Okay. If you want to write c3, that's okay too. All right, I'm checking my work really quick, and that's it. We done these.